In this video, I want to talk about ODE45 event functions. And I'm going to do this in the context of the same example we've been using, which is this mass on a spring shown here. And just as a reminder, our state variable vector that we've described for this example is x and x dot. So if we went ahead and simulated this as we did in our previous videos for 10 seconds, given an initial condition of position 2, velocity 0, this was our output plot of the x position. And we simulated this for 10 seconds. But let's suppose the scenario that we didn't just want to simulate for 10 seconds, but we wanted to simulate for one full oscillation. Perhaps we needed to know what the time of the oscillation was, and so we wanted the simulation just to go for one full oscillation. One way of doing this is to vary your time span so that rather than it ending at 10, you tinker around with it and have it ending, let's see, it looks somewhere like 6.15, 6.2. But that can be really tedious. And I guarantee you MATLAB will be more accurate than you or I would be doing this visually. And so that's where these event functions come into play, is that they can automatically detect when an event has occurred and either stop simulation or flag it, depending on what you tell it to do. Now, these event functions are quite simple to put together, and they're also another function that you need to point ODE45 to. So we'll describe it here, and then we'll implement it in MATLAB next. So an event function has three outputs. It has a value output, an isTerminal flag, and a direction. And the inputs to your event function are time and your state variable vector. You can also pass in parameters using the same technique that we described in our last video, but for now, I'm just going to leave it as time in our input vector. Now, this function can be described just in 3 lines of code. All we need to do is define what val is terminal, and direction. So the value is basically telling MATLAB to stop simulation when val equals 0. So in our case, if we want to stop simulation at this point up here, this would be a scenario where the slope equals 0. And the slope of our system is represented by the second index of our state variable vector. isTerminal basically tells MATLAB whether or not to stop simulation or just flag it. So this can either be a 0 or a 1. If it's a 0, it basically says MATLAB just to flag it, and there's a way to output that flagged time step and state variable vector, or you can tell it to stop simulation by just having it set equal to 1. And that's what we're going to be doing in our example here. Now the direction, you have 3 options. It can either be a -1, a 1, or a 0. What this says is that the passing of the value across 0 either has a negative slope, a positive slope, or if you select 0, it says, I don't really care which direction the slope is. So you might have been looking at this and saying, well, yeah, the slope is 0 up here, but it's also 0 right here. So how do I tell MATLAB, ignore this one, but make sure to stop at this one? Well, you can do that using this direction. So you can see the slope before this crossing here is a positive slope, and then it goes to negative. So it's going from a positive number to a negative number, which a line going from a positive number to a negative number has a negative slope. So in our example, we want to be using -1 for our direction. If we used 1 or 0, it would stop at this first crossing of slope equal to 0. Let's go ahead and implement this in MATLAB. All right, so here's our example script that we've been working through in a couple of these videos. Now I want to go ahead and create a new function to point the script to for my event function. So I'm going to go ahead and select a new script, and I'm going to start it out by defining as a function with 3 outputs, val, isTerminal, and direction. And let's call this spring event, and the inputs will be t for time and s for a state variable vector. And I want to define my 3 outputs. So value we said would happen when the slope is equal to 0, which is S2. isTerminal, we said we want it to stop simulation, so we're going to put it as a 1. And our direction we said was -1, in which this crossing occurs. So I'm going to go ahead and save this in the same directory as the script itself. And then I just need to point MATLAB towards this. And I'm going to do that using something known as ODE_set. So you can set a number of options for ODE45. So I will create a variable known as options, and ODE_set I can use to define a number of different things, but in this case, we'll just use it for the events. So I want to point it to the spring event function using a function handle. And then I need to tell ODE45 to use this options variable. So the fourth input to ODE45 can be this options variable. If you want to play around with other options, go ahead and look up ODE_set on MathWorks help page. So now if I go ahead and run the script, you can see that the function only simulated to this second crossing, despite our t-span being 10 seconds. So it automatically said, oh, the ODE event function was hit. The way that ODE45 is using this event function is that it's starting at an initial condition and it's simulating forward. And with each time step forward, it is checking the event function. It is saying, here is my time step t, here is my state variable vector s, is value equal to 0? And if it's not, it keeps going forward. But when value equals 0, that is when things stop. So because it stopped here, and despite t-span going to 10, if we look at our t-out vector, specifically our last entry, you can see that t-out, the last entry of it is 6.28. So the period of oscillation of this spring would be 6.28 seconds. Now I said earlier that if we had changed this direction to 1 or 0, it would stop at that first crossing, and I just want to show you what that would look like and prove to you that that is the case. So if I set it to 0, it says, I don't care about the slope, just stop at the first crossing of 0. And here's that plot. So it just simulates for a half oscillation, or that first crossing of 0 of the slope. Now you could also use the event function to stop the simulation at a value that is non-zero. So what if I wanted to stop the simulation? Let's bring it back to what we had. Let's suppose that I want to stop the simulation when the mass crosses, let's say, position 1 the second time. So I want the simulation to stop right here. Well, now I'm concerned with position, not necessarily slope. But that position doesn't equal 0 there. It actually equals 1. So I need to kind of be clever in how I describe or set the value in the event function. So going back to our event function, if I want the position to equal 1, I'm going to have to do position minus 1. So notice that when the position's less than 1, it is going to be a negative number, and then when it is larger than 1, it'll be a positive number. So this crossing for the second crossing is going to be from a negative number to a positive number, so that's a positive slope. So the direction would be positive. So now if I go ahead and simulate this, we expect it to stop at that second crossing of 1, and that's exactly right. And if I hover over here, you can see that the time at which this occurs is 4.712 seconds. If I left direction as -1, or if I left it at 0, it would do this first crossing right here. And just to show this as an example, let's go ahead and change this to a -1 or 0. And there you have it. These event functions are super powerful and super useful in doing numerical simulations where you need the simulation to stop at a specific point. If you want to know more about these ODE45 event functions, I would really suggest reading up on them on MathWorks' website. Thank you.